carbon metabolism, translocation and distribution of photoassimilate. So for this chapter, you will learn about 3 cycles, which is carbon cycle, hydrogen cycle, and oxygen cycle. And these 3 cycles is related with the photosynthesis, either light independent reaction or light dependent reaction. Now first we look on the learning objective for this chapter. First, you need to understand the biochemical pathway that lead to the synthesis of starch and sucrose. So the carbon compound that you need to learn in this chapter is about starch and sucrose. Okay, and then you need to know how the carbon provided by the photosynthesis, okay, through their carbohydrate sources, okay, that produce is allocated to starch or sucrose synthesis. Okay, and the third one is understand the nature of the phloem tissue and its role in the transport of photoassimilates. You need to know that in this chapter you not learn about the xylem, because xylem they carry the water and dissolved material. But for today you learn about the carbon compound, which is we focus on the starch and sucrose. So we want to see how these two form of carbohydrate, okay, can be used by plant. And learning objective number 4 is you need to know the mechanism of the phloem transport and the importance of source to sink relationship for transport. Okay, in this chapter also they have certain terms, new terms for you that you need to understand what they are meaning. Okay, for example, sucrose to sinks. That means because for this chapter you learn about 2 form of carbohydrate, which is starch and then the sucrose. So the source is where the area that produce the starch, which is leaf. Okay, and then from leaf, okay, starch will be degrade and become the sucrose, and this sucrose will be transported to other area of plant. So other area that require the starch we call as sink. So they have a movement, okay, from the source to sink. So that means by source to sink relationship for transport. And the last learning objective is you need to recognize some xenobiotic compound that can enter the phloem and also can be translocated internally. So means not only sucrose can be transported using the phloem, but you need to know also they have the compound that we call as xenobiotic, okay, that can transport also using this tissue, okay, which is a phloem tissue. Alright, now we look to starch and sucrose synthesis. For the photosynthesis, they produce simple hexose sugar, is it? Because they produce the glucose. Okay, glucose is hexose sugar, which is 6 carbon sugar. So this used by plant to synthesize the starch and sucrose. So means the final form of the carbohydrate is not the glucose, but okay, in form of starch and sucrose. So all the sugar that they produce during the photosynthesis are devoted to starch or sucrose synthesis. We call this process as a carbon allocation. So that sugar consists many of the carbon. So this carbon will be allocated, okay, become sucrose or become starch. Okay, then you need to know also starch is a storage form of carbon. Okay, and for the sucrose, you can say that the sucrose is the primary form in which carbon is transported over long distance in the plant. Means starch is the storage form of carbon that give a storage energy to plant. However, when another parts of their body require the carbohydrate, the sugar, this starch should be synthesis the sucrose. Means from the starch it will be synthesis the sucrose, because sucrose is only the primary form that the carbon can be translocated from a long distance in plant. Now we look on the starch synthesis. So you need to know that starch synthesis in the chloroplast, which is in the stroma. So you know that chloroplast in the leaf, okay? Because leaf is the main organ for the photosynthesis. So this is really related with the photosynthesis because starch is synthesis from the sugar that produced in the photosynthesis. So for starch, you need to know they have two types, which is they have amylose and they have amylopectin. Which is for the amylose, that is the starch in the linear form, okay, straight form. And you know that starch is from the building block, their building block of glucose. So they have a lot of the glucose. So because of that, we call this starch as glucose polymer. So for the amylose, they are linear glucose polymer, okay, from the alpha 1,4 linkage. Why we call as alpha 1,4 linkage? Because this glucose is alpha glucose. Okay, you need to remember also for the glucose, they have alpha glucose and they have beta glucose. So for starch, they are using alpha glucose. So when one glucose bind to another glucose, okay, one glucose, for example, glucose number 1 with glucose number 2, okay, they join together by link 1, 4 at carbon number 1 and at carbon number 4. So the name of that linkage we call as glycosidic linkage. Okay, and another starch we call as amylopectin. Okay, because amylose, they are linear glucose polymer, but different to the amylopectin, which is this amylopectin, they are the branches glucose polymer, okay, that will be make up as one of the starch. So this amylopectin, okay, they are similar to the amylose because regarding to they also have the linear glucose polymer. However, from the linear, they have the branches. So because of that, at the branches of the glucose, they have different linkage, okay, which is they have alpha 1,6 linkage. Okay, they also have alpha 1,4 linkage for their straight glucose polymer. So means this amylopectin, they have alpha 1,4 and they also have alpha 1,6 that will create their branches chain to the structure of the amylopectin. Alright, now we move to the process. Okay, only general process on starch synthesis is different to the photosynthesis process that you need to know one by one of their steps. Okay, for the starch synthesis, you need to know only general explanation. Okay, for starch. So for example, this synthesis of starch is begin with the hexose phosphate pool, which is coming from the sugar synthesis from the photosynthesis. Because photosynthesis produce glucose hexose sugar, 6 carbon sugar. Okay, hexose phosphate because they have the phosphate group. Pool, what's mean by pool? Pool means many of the hexose phosphate. Okay, and it's produced by PCR, okay, which is photosynthesis and carbon metabolism. Means this synthesis of starch, okay, could be produced in during two process, okay, photosynthesis and carbon metabolism. So for this both process, fructose 6 phosphate, okay, is converted to glucose 1 phosphate, okay, by enzyme we call as hexose phosphate isomerase and phosphoglucomutase. Okay, then that glucose 1 phosphate react with ATP. Okay, so they react with ATP, okay, to form ADP glucose, okay, not ATP. So they remove the inorganic phosphate, okay, use the enzyme or mediated by ADP glucose pyrophosphorylase. Okay, so that is the name of the enzyme. So here in this process, okay, they given to you three names or three different enzymes, which is hexose phosphate isomerase, phosphoglucomutase, and also ADP glucose pyrophosphorylase. Okay, and when we look on the figure, you can see the process of the starch. So you see first the green color, because now we look on the starch synthesis, where starch synthesis, as I mentioned before, they occur in the chloroplast. And in this part, this is regarding to the mesophyll cell. Why mesophyll? Because for the starch synthesis, they occur in chloroplast. Okay. However, for the what we call for the sucrose synthesis, they occur in the cytosol of the mesophyll. So they really so this process is interconnected, okay, between two synthesis the starch and after that synthesis the sucrose. So now we look on synthesis of the starch. Okay, in the general mechanism, you can see here using the photosynthesis process means using the dependent reaction because here they are using a light and they require the CO2. Okay, during the photosynthesis process, so they produce the triose phosphate. Okay, means sugar that have 3 carbon sugar with phosphate group. And with many of or a collection or accumulation of the triose P, so it will make a hexose sugar. So this hexose phosphate can become many, okay, and we call as hexose phosphate pool. And hexose phosphate pool will be removed their inorganic phosphate and synthesis the starch. Okay, that is about the synthesis of starch in chloroplast. However, in that process, so you need to know that fructose 6-phosphate convert to glucose 1-phosphate, which is this both is the name of hexose sugar. Okay, so from the hexose P pool should be fructose 6-phosphate convert to glucose 1-phosphate. Okay, then in hexose P pool, okay, glucose 1-phosphate react with ADP because now okay, they remove the PI inorganic phosphate and form ADP glucose. So this process is intermediate by ADP glucose pyrophosphorylase. In order to synthesize the sucrose from the carbon of G3P and DHAP, you need to know some principal pathway, okay, that mediated by enzyme that we call as sucrose phosphate synthetase and sucrose phosphate phosphatase. Okay, so then UDP glucose, which is uridine diphosphate glucose, react with the fructose 6-phosphate to form sucrose 6-phosphate and then release the UDP. Sucrose 6-phosphate is dephosphorylated to form sucrose. So because of that, at last they can get the sucrose because sucrose 6-phosphate is remove their phosphate at carbon number 6. So this slide means they have two principles in order to produce the sucrose, which is using two enzyme or using one enzyme which is sucrose synthase directly can produce the sucrose from the glucose and fructose UDP. It's different to the starch synthesis where the glucose should be activated by ATP. So glucose for the sucrose synthesis activated by the UTP because UTP become UDP. Okay. However, for starch, they're not using UTP but they are using ATP. So now we look on sucrose and starch synthesis are competing processes. So the principal factor determining the balance between sucrose and starch synthesis is the cytosolic enzyme that we call as fructose 1,6-biphosphate phosphatase or FBPase. This enzyme represents a key regulatory in order to flow a carbon into the sucrose. And FBPase can be inhibited, okay, by the regulator metabolite we call as fructose 2,6-biphosphate, okay, F26BP. So means this F26BP is the inhibitor to the FBPase. So this is a structure of fructose 1,6-biphosphate and their inhibitor, which is fructose 2,6-biphosphate. So this fructose 2,6-biphosphate, they are mimicry to the fructose 1,6-phosphate. So because of that, they able to bind at the FBPase enzyme. Now we look on composition of the phloem sac. Phloem sac is a liquid of phloem. So phloem sac is a mixture, okay, a complex mixture of organic and inorganic compounds, okay, such as sucrose and other sugars, okay, protein, also amino acid, organic acid, okay, anion and cation, and also the phytohormones. Proteins and the phloem. So phloem, they contains aggregates of protein that we call as pea protein bodies. So if in the test or in the final exam, they always select this part, okay, as the question that will be asking you regarding to this chapter. So you need to know the role of pea protein bodies. So this function, okay, the function for pea protein bodies is they involve in plugging the sieve plates of damaged cell. Means their function is to seal off the damaged phloem cell. Not only pea protein bodies that can plugging the damaged phloem cell, they have another sugar we call as glucan, or their specific name is callose. This slide show you the directional of phloem transport. You need to know that phloem transport move photoassimilate, okay, such as their sucrose from source to sink. And you need to know what is source, okay, what is sink. So source is an area, okay, an area such as a storage organ or photosynthetically active leaf or leaf, okay, that is capable of exporting photoassimilate. Means source is area, okay, is an area that produce the starch, and it's capable to export that starch in form of sucrose. And what is a sink? A sink is an area that must import, okay, import photoassimilate to support their metabolism. You know that in your body also your cell have different metabolism. Same also as plant. So plant cell, they have their own metabolism. So in order to support their metabolism, they require the sugar, which is carbon compound. So because of that, another cell at another area, okay, they require this photoassimilate. So because of that, they need to have the directionality, okay, from source to sink. So sources and sinks within a plant can change in response to developmental age. Means they have some changing, okay, regarding to development of age. Mechanism of phloem transport. So the current accepted model for phloem transport is we call pressure flow hypothesis. So using this pressure flow model, the phloem sac is driven by a positive hydrostatic pressure. So what you need to know for the mechanism, they are using a model that use positive hydrostatic pressure from source to sink. Okay, and this phloem transport is tightly linked with transpirational water flow in the xylem. Even though in the previous slide I told you it's not related to the xylem, okay, directly, but indirectly they always connected together, okay, because in order phloem able to transport their carbon compound, they need always have the impact from the transpiration of water in the xylem tissue. Now we look on a new term, which is allocation and partitioning. Okay, so some of the photoassimilate are retained, okay, which is starch, within the photosynthetic leaf, okay, and the rest can be export. So the export photoassimilate should be the sucrose. So the distribution of those export, which is the sucrose, to various processes, okay, involve allocation and partitioning. So what is allocation? Allocation is the metabolic fate of photoassimilate. Okay, either the carbon compound from the photosynthesis can be as starch or can be as sucrose. So we call as that metabolic fate. Okay, so metabolic fate we call as allocation. So some of the photoassimilate are stored in the photosynthesizing leaf to support the metabolism. So not all photoassimilate can be export, okay, from the leaf to zinc, but some will be leave at leaf area internally in order to support their metabolism. And bulk of photoassimilate are export. So means a large number of the photoassimilate are export to the another area. What is the partitioning? Okay, partitioning means the distribution of photoassimilate, okay, between zinc. Okay, for the allocation regarding to source, okay, they have some of the photoassimilate remain at the source, and huge number of the photoassimilate can be transported to the zinc. Now, partitioning is regarding to from distribution zinc to zinc. Okay, so that is partitioning. So partitioning can be defined by competition between zinc tissue. So which zinc tissue can get more carbon compound in form of sucrose. So for the zinc strength is the function of zinc size and zinc activity. So the zinc strength is based on size and also based on activity of the zinc. So zinc size is referred to the biomass of zinc tissue, which is area, the size of that area. Okay, that usually we count as their dry weight. And zinc activity is the rate of the uptake of assimilate per unit biomass per unit time. Now we move to the last subtopic in this chapter regarding to the xenobiotic in the phloem. So xenobiotic is a synthetic chemical, okay, with the appropriate lipophilicity, okay, which is philicity is regarding to ability to dissolve in fat, oil, a lipid or non-polar solvent, okay, such as hexane or toluene or another alcohol, and also can be transported in phloem. Means this xenobiotic is not the photoassimilate compound, but they also able to transport using the phloem in plant. So this is related to our agrochemical industry, which is using this application of xenobiotic, okay, they able to relate with the internal distribution of herbicide, okay, or pesticide or the growth regulator. So one example of the xenobiotic that always used in agrochemical industry is herbicide glyphosate. So this glyphosate, okay, apply to leaf, okay, enter the phloem and transport to the root, okay, where it can interfere with the aromatic amino acid metabolism. So when this enter the root part, so it prevent the plant from making certain protein that needed for plant growth. So because of that, it able to control the weed problem.
On a Saturday night in the summer, sundown and they all come out. Lamborghinis and they rented hummus. The party's on, so they're heading downtown. Everybody's looking for a come up, and they wanna know what you're about. Me in the middle with the one I love it. We're just trying to figure everything out. We don't fit in well, cause we are just ourselves. I could use some help getting out of this conversation. Yeah, you look stunning, dear, so don't ask that question here. This is my only fear, that we become beautiful people, top designer clothes. stars in your eyes when we're halfway there. Now I'm not fazed by all the lights and flashy cameras, 'cause with my arms around you, there's no need to care. We don't fit in well, we are just ourselves. I could use some help getting out of this conversation here. Your looks done in this, so don't ask that question here. This is my only fear, that we become beautiful people. Top designer clothes, front row fashion shows. What you do and who'd you know? Inside